Hello, and welcome to our videos for Math 152, Multivariable Calculus this semester. So over the course of the semester, instead of having formal lectures, I'm going to be recording these videos. Many of them are already recorded and will be posted. I'll be recording more in the future. And watching these videos is what's going to replace our lecture for the semester in this asynchronous course. And so these videos will typically be around 5 to 10 minutes long. Sometimes they'll be shorter than 5 minutes. On rare occasions, they will go longer than 10 minutes or so. I try to not make them too long. But hopefully this format of being able to watch one video at a time before going on to the next video will be conducive to your learning this semester. Okay, so the first chapter of this course, Multivariable Calculus, Chapter 12, Vectors and the Geometry of Space. So multivariable calculus, more than one variable, it's going to be calculus of more than one variable. And so a lot of what we do is going to be three-dimensional stuff. Vectors, so we'll learn about vectors, and the geometry of space. And when we say space here, we mean three-dimensional space. I will also sometimes call this R3. Instead of saying space here, R3 would just mean three-dimensional space. It's the set of points with three components to them. And so you and I, so let's move into section 12.1. You know, we've done lots of work, you know, all throughout your math career. You've been having coordinate planes here, the XY plane, and you can do things like, okay, this is the 1, 2, 3, 1. Okay, this is the point, X is 3, Y is 1. But what we want to do is that we want to kick it up a dimension. So instead of having things in 2 dimensions, we want to have things in 3 dimensions. And of course, this better reflects physical reality. You know, I don't know how hard it will be to kind of tell what I'm doing on the camera, because camera does, you know, record the 2-dimensional picture of 3-dimensional reality. But I can move in this direction. I can move in this direction, and then, you know, this is, you know, coming up towards the camera, up and down. So this is, you know, from my perspective, sitting here looking at this is forward and backwards, left and right, up and down. And so what we will end up doing is that we'll end up having these three-dimensional axes, you know, sets of axes here, a three-dimensional coordinate system, X, Y, and Z here. And so now instead of locating points with 2 coordinates, we can locate points using 3 coordinates. So, okay, so I might go, let me just put some tick marks here. Okay, so let's see, what happens if I want to look at the point 3, 1, 2. So that says that X is 3, Y is 1, Z is 2. So here's 3 tick marks along the positive x-axis. 1 tick mark here. So that would be like in the plane, but then we need to, so we go walk 3 units this way, 1 unit this way, and then 2 units up. And so this point right here corresponds to 3, 1, 2. So it's 2 units floating above the XY plane at that point right there. I should make a couple points here that I only drew the positive X, Y, and Z axes. And so, like, you know, behind this, there's a negative x-axis going in this direction. There's a negative y-axis going down here. And there's a negative z-axis going below our surface. And so this is how you get these kinds of This is how you draw these three-dimensional coordinate systems. So the next thing I want to talk about is what order do we do these in? So you and I know that, like, okay, this is X, this is, I draw axis, you just know automatically you're going to label this X and this is Y. In this kind of setting, how do we know which one's X and which one's Y, which one's Z? And so the answer to that is we have, the rule that we use to construct these is we're going to call these right-handed coordinate systems. And so this one right here is an example of a right-handed coordinate system. What do I mean by that? So let me once again draw X, Y, and Z like this here, with this is the positive x-axis, this is a positive y-axis, this is the positive z-axis. So what we do is that you're going, so it's a little bit difficult for me to demonstrate this in the video, but I suggest trying this yourself, maybe after I show this, pause the video and try this out for yourself. You're going to take your hand and you're going to point it in the direction of the positive x-axis. And you're going to take, and you want to be able to point your fingers so in the directions they can curl towards the positive y-axis. And if you do that, your thumb should be pointing straight up towards the positive z-axis. So point fingers of your right hand towards the positive x-axis and curl towards positive y-axis, and your thumb should be pointing to the positive z-axis. So this is how you make this kind of determination, which one, X, Y, and Z. So they have to be in this kind of order here. And so if you were to flip-flop, let me just draw, a wrong example here. If I were to say this is positive y-axis, this is positive y-axis, this is positive x, this is positive z, I point my fingers in the positive y direction, I try curling them towards the positive y direction, and my fingers pointing down, not in the z direction. So that is what we mean here by right-handed coordinate system. It's important for you to, just want to know, it's important for you to use your right hand, not your left hand when doing this. If you use your left hand, you'll get the wrong answer. So for those of you who my wife is left-handed, many of you, are probably left-handed. If you are left-handed, this is one situation where you do need to use your right hand.